Hey everyone, today we're going on a deep dive, investigating something that's all around us but completely invisible. It's in our homes, our cities, and, well, with every single breath we take, it's in our lungs. We are talking about air pollution. And believe me, what you can't see can absolutely hurt you. No, really, think about it for a second. We take something like 20,000 breaths every single day. But what are we actually pulling into our bodies besides oxygen? The answer to that question impacts our health every moment of every day. You see, mixed in with the air that keeps us alive is this complex cocktail of pollutants. And figuring out what they are, where they come from, and the effect they have on us, that's absolutely critical. So let's break it all down. All right, so let's start at the beginning. What do we actually mean when we say air pollution? Because it is so much more than just the smog you might see hanging over a city or, the smoke coming out of a factory.
So here's the key. We're talking about harmful substances, and they really do come from everywhere. You've got natural sources like volcanic eruptions or forest fires, but then you have all the man-made stuff like car exhaust and industrial manufacturing. It all gets mixed together up there.
Now, to really get a handle on this, you got to know about a really important distinction. See, scientists don't just lump all pollutants into one big category. Nope. They split them into two main types based on how they're actually formed. And this cooking analogy, it is perfect. Think of primary pollutants as your raw ingredients. They get shot straight into the air from a source. But secondary pollutants, they're what you get when those raw ingredients mix together and cook up in the atmosphere, with sunlight often acting like the oven. And that new recipe can be even more dangerous. So let's talk about those raw ingredients first. These are probably the ones you've heard of. We're talking carbon monoxide from your car's exhaust pipe, sulfur dioxide from power plants burning coal, and of course, all that fine particulate matter, the soot and dust that makes the air look all hazy. And when those primary pollutants start reacting up in the air, you get this cooked stuff. The most famous one is ground-level ozone. That's the main villain behind photochemical smog. Now, this is not the good ozone layer way up in the stratosphere that protects us. Oh no, this is the stuff down at street level that is seriously damaging to our lungs and to plants. Okay, so we've got all these pollutants floating around. So what? Why does this actually matter to you and me? Well, because the cost to our health, to our environment, and even to our wallets is just staggering.
I mean, in the short term, you can literally feel a polluted day. You know that scratchy throat, the watery eyes, maybe a headache that comes out of nowhere. For anyone with asthma, it can be an immediate, serious problem. It just weakens our body's defenses.
But the long-term damage? That's where things get truly frightening. We're not talking about a temporary headache anymore. We're talking about chronic, life-changing diseases. Years of exposure can permanently damage your lungs, seriously increase your risk of heart attacks and strokes, and even cause neurological damage, which is incredibly dangerous for kids. And the damage doesn't just stop with us. The entire environment is suffering. These pollutants literally coat the leaves of plants, basically choking them by blocking out sunlight. They also cause acid rain, which poisons the soil and our lakes, throwing entire ecosystems completely out of whack. Now get a load of this number. That secondary pollutant we just talked about, ground-level ozone, it is so toxic to plants that it's responsible for an estimated 90% of all crop damage from air pollution. That's a direct threat to our global food supply. And if that wasn't enough, here's a cost that's almost hard to believe. Air pollution is literally eating our cities. The pollutants in acid rain corrode metal and stone, damaging our bridges, our buildings, our historical monuments. That decay costs the world over 3% of its entire GDP every single year.
So if most of this stuff is invisible, how in the world do we know it's even there, let alone how much? This is where the amazing science of air monitoring comes in. It's all about making the invisible visible.
So the gold standard for this kind of work is a technique called active sampling. The concept is actually pretty simple. You use a special pump that acts like a tiny mechanical lung. It breathes in a very specific amount of air and traps all the pollutants on a filter so scientists can study them. So here's how it goes down in 3 simple steps. First, that special pump pulls in a very precise amount of air. Second, all that air gets forced through a filter that was already weighed in a lab, and that filter traps all the tiny particles. Finally, they take the filter back to the lab and weigh it again.
That tiny little difference in weight, that tells them exactly how much pollution was in that sample of air. Pretty clever, right?
Okay, so we can measure what's in the air with incredible precision. But how much is too much? Who gets to decide what level is safe? And that brings us to the really crucial idea of air quality standards. See, to protect public health, governments all over the world set legal limits for the big pollutants. And these are not just suggestions. They are enforceable ceilings that are not supposed to be crossed. We're going to use India's National Ambient Air Quality Standards, or NAQS, as a perfect example of how this all works. This table right here shows you how that policy gets turned into hard numbers. For each major pollutant, there's a specific concentration limit. That's the micrograms per cubic meter part that shouldn't be exceeded over a certain amount of time. So for example, you can see the 24-hour limit for those really dangerous little PM 2.5 particles is 6. And that right there leads us to the final, most important question. It's one thing to have these standards written down in a book. It's another thing entirely for the air right outside your window to actually meet them. And the gap between that standard and reality, well, that's where the real challenge for our health and for our future truly lies.